day 1. So basically with this U-substitution methodology that we're going to be using, we're going to use only the power chain rule. All right, and the power chain rule is much the same as the power rule of integration that we covered yesterday. And so the power chain rule says that if we integrate a function u, now it's not an x, but it's going to be like the same thing, to the n du, this is equal to, same idea, u parentheses n plus 1 multiply by 1 over n plus 1, the reciprocal, plus the constant of integration. All right, so it looks the same. Now, the trick in here lies in this idea of u and du. All right, so u is a function of x, and du is the derivative of x, dx. The main concept here, so when we took derivatives, so in terms of a quick review of the chain rule, if we took the derivative of x squared plus 4 to the 5th power, all right, then we would have gotten, bring down the 5 for differentiation, keep the baby, x squared plus 4 to the 4th power times 2x. Okay? So it stands to matter, which is equal to x squared plus 4 to the 4th power times 10, or no, we'll keep it like that actually. So the main premise of what we're going to be doing is focusing on this piece right in here, because there's my u and my du. So if I were to integrate, right, 5x squared plus 4 to the 4th times 2x dx, it stands that I would get 5. Okay, and the 5 comes outside, and then I would get parentheses x squared plus 4 to the 5th 1 over 5th plus c. And the reason why this holds, because this piece right in here, this right here is u, and this right here is my du dx, which makes this piece over here the entire thing du, because you can see kind of like the dx's cancel each other out. I know it looks a little weird, and I'm going to get to there. I'm going to get more to a more algorithmic type way. So we get x squared plus 4 to the 5th power plus the constant of integration. But I mean, the main idea here is we got what we started with. So what this amounts to is what we call a change of variables. And a change in variables is when we substitute a variable for an expression and change all other parts as well to reflect. And in this case, what we're going to be doing here in this case is that we're going to substitute u, so we're going to have some function of x that we're going to define as u, and as such, dx will also equal the derivative. Oh, sorry, I'm doing it wrong. I don't know why I did that. Du would therefore equal to some derivative function g prime of x dx. Now, when we substitute, we want to be able to recognize this g of x, which I refer to as the baby. That's the chain rule part that's going to be trapped inside of a function. Trapped in parentheses. Typically. Almost always. And this is going to be attached. Now, this last part becomes a little bit trickier because we don't always get the exact derivative of g prime. And in reality, what happens, as we see in the top problem, and we need to note this, is that g prime of x dx will usually be off by a factor. In other words, a constant. And so we will compensate for that. I know that's a lot to digest. Let me let you catch up in writing that. The process here, though, is very algorithmic. You do this, then you do this, then you do this, then you do this. And if you remember back to, as you're writing this, if you remember back to when we first did derivatives, you know, and we only were doing power rule type problems, you know, we're like, oh, and we're like, you guys were like, that's so hard, I don't understand these. And then we moved into the other ones, and you're like, well, wait, why can't we go back to the power rule problems? Those are so much easier when they were all just those. Now I have to decide if I have to do this problem or this problem. Well, the good news is that the only chain rule, the only U-substitution method that you're going to be using is power rule. So every single problem will all end with something to some power. Now, you do have to be careful in one instance, and that instance is that some problems might just be basic like yesterday, all right? I didn't put any problems in your homework where you might not have to use substitution. As we will practice, I get a lot of students who believe they have to use substitution where you can't use substitution and therefore bad math happens. I will show an example of that one today in regards to, remember, you can always expand. I mean, that's the main thing I want just to remind you. You can always, if you can expand the function out, typically you just want to go at it that way, all right? All right. So let's do an example with the explanation of steps. All right. So let's go back to that very first problem that we just did. Let's try it without the 5x, without the 5. So if we were just trying to integrate x squared plus 4. Actually, let's change it slightly. Let's go to the 5th power. Now we'll go to the 4th. Keep it the same. Dx. Now, we kind of know what our answer is going to look like. If you think about the idea, you know, and this also becomes part of the problems when you do multiple choice, is that if you're struggling with integration, you can always look at the answer choices, A, B, C, D, and determine from those ones which ones, if you took the derivative, would give you x squared plus 4 to the 4th, all right? So sometimes if you look at a problem and say, well, if that was the answer, if I took the derivative of that, I'd have to use the product rule. oh, well, if I use the product rule, then my answer would be off. Would have to have two terms, and I did miss something here. I'm going to put an X right in front. Sorry about that. So sometimes you can look at answers and be going, oh, something's off. Please add that X. Now, when I look at this problem, I could expand. I could go x squared plus 4 times x squared plus 4 times x squared plus 4 times x squared plus 4. But that doesn't seem reasonable. And then I have to multiply that by x. This problem is not meant to do that. Now, what's very important to do here is, step 1, recognize U-substitution required. And so requirements met. What I mean by this is, first, you need to find some type of composite. You want to identify a baby, which is a composition function, and confirm that derivative of baby is in the integrand. Don't worry about constant. So when I look at this problem, I see a baby. I see something trapped in parentheses. Now, also, how do I know this? If multiple functions of x within integrand most always a U-substitution problem. All right, and what I mean by that, so I'm giving you guys a lot of insights, and these are insights that, for me, I've taken them over the years, and they're skills and tricks, and here's the truth. You only get better at these, and you only start to recognize these and be able to do it with the more problems you do. All right, so it takes a lot of practice with these problems. All right, so I try to keep the homework down. I think each day's problems is like 6 problems of today and the next 2 days of class or homework handouts, and they might feel a little long at times, but believe me, they're all worth it. Okay, so let me go into here. So I look at this function and I see x and I see x squared. All right. And I can't combine the x and the x squared because there's these parentheses raised to the 4th. So I can't combine them. This is a sure cell sign that I need to use U-substitution. All right. I see x squared. Okay. Everything now, my gut, as I say, my gut tells me U-substitution will be needed on this problem. It doesn't actually mean that. Okay, that can be off. All right. I identify the baby. So the baby seems to be U in and let me write this. So my baby. So I'm going to say check on this one. My baby is x squared plus 4. okay? And I think about x squared plus 4, and I ask myself, okay, what's the derivative of x squared plus 4? You should be feeling very comfortable to kind of do these in your head. And you don't have to be, you don't worry. So it's 2x. All right. Now I said don't worry about the constant. So I think if I chop off the constant, I get x. Is my other function of x in there? Do I see an x in my problem? Yes or no? Is there an x? Is there a plain old x attached, being multiplied in the integrand? There is the answer is yes. So I look at my x squared plus 4, and then I look at the other one. Now this is my baby, and I look at the x, and that comes from the derivative. So those are the two things I'm kind of trying to check. Okay, x squared plus 4 can be my baby, and if x squared plus 4 is my baby, then the derivative is the derivative also there. Now these are quick checks. Now sometimes a lot of people don't even do this step 1 check, and they just plow right into them. And in the majority of the time, you're going to be correct. As long as you check to make sure there's two, if you see two things of x's, 9 times out of 10, that's the answer. All right. Now, if you do not see two functions of x, that does not mean you could still have U-substitution, but it's a little bit trickier in those situations. And also, you can get problems where you have two functions of x, and it turns out that you could have just expanded, and so the problem doesn't allow it either. Step 2. Define the baby as u. Okay? So, in this case, u is what? What is trapped? And typically, u will have multiple terms. Okay. X squared plus 4. All right, so u is x squared plus 4. Step 3. Differentiate partially, and I'll say what this partially means. This partially means, actually I'll do a differentiate partially and do a comma. Du dx type of thing, and solve for terms of x. This one's a little bit weird in terms of the way I solve it, because this is where some people do it a little bit differently. So what I'm going to do here is I'm going to take the derivative. Now, there's not going to be fractions. So we say the derivative of u is du, which is equal to the derivative of x squared, which is 2x, the derivative of 4 is 0, and then dx. Now, technically what you can say is, basically what we're saying here is du dx is 2x, and then therefore du is equal to 2x dx. That's kind of that's like what we're doing, but we go directly to du equals 2x dx. What I mean by solving in terms of x is that I want to solve for just the x and the dx's, all right? So I'm going to solve for the x dx, which means technically what I'm going to do is I'm going to divide by 2. It's just constants. You know, if it's times 2, then it becomes 1/2 on the other side. If it was divide by 2, then it becomes times 2 on the other side. These are just going to be constants, all right? And so x dx is equal to what?
repeat du over 2.
Du over 2. And for my purposes, I hate to use the division, so I'm going to say 1/2 du. It makes it much easier to do. So u is x squared plus 4, or x squared plus 4 is u, and x dx is 1/2 du. Now, there is another way of trying to doing these type of problems. I'm not a fan of it, and well, what happens is you got to kind of pick one of the two methods. So I will briefly explain the other method in case a tutor or another friend or somebody you work with in calculus tries to work with you. In the other method, it says 2x dx. That means I need a 2x dx. Well, I don't got a 2x. All I got is an x. And so what the other method would do is it'll say, all right, I don't have a 2x, let me make a 2x. So if I put a 2 next to the x and I put a 1/2 out in front, this will compensate. This can work for some problems and make some easier, but in the end, you have to pick a method. I prefer the method that we're going to do, but this is the other part that in case you do see someone show it to you, that's how you would do it. You go like, oh, well, I'm going to put a 2 and a 1/2, and that's how now I have a 2x. I say, hey, let's just always solve for the terms of x. All right. Step 4. Substitute the baby for u and the terms of x slash dx for k du. And so we've just found what the constant is. You can place the k in front of the integral. So just as a reminder for our problem was the integral of x parentheses x squared plus 4 to the 4th power dx. Now, hopefully you can see this. Remember, a times b times c is the same thing as b times c times a. In other words, I can kind of move the multiplications around. So what I mean by that is that this is the same thing as the integral of x squared plus 4 to the 4th times x dx. Some students like to rewrite this as this step, but most of the times we can just see, okay, I have x dx. That's what I need to make sure I have because I see x dx right here, or you can just move it and move them next to each other. Now, basically what we're doing here is we're going to say, all right, I'm going to replace the baby, my substitution. So my first substitution was that u is x squared plus 4. So I'm going to take that x squared plus 4 and replace it with a u. So I get the integral of u to the 4th. And what I'm going to do is I'm going to replace the x dx with 1/2 du. But what I'm telling you to do is that you see this 1/2 right in here? Well, I can bring this out into the front. So when doing this problem, you really just want to go from here to here and say, all right, this becomes, I see this 1/2 right here. So I'm going to get 1/2 the integral. And I'm going to replace the x squared plus 4 with u, so that becomes u to the 4th, and it always becomes du. These problems will always end up looking like this. All of the problems that you do today, the next 2 days. We'll always get to a point after you've done this problems, they will always get to a point where you get some constant times an integral of u to the n du. They all lead there. Okay, step 5. Integrate using, which is really just integrate. In this case, using power chain rule. Now when you get to, and we will learn some other functions, and then we're going to use, we're going to be on the U-substitution for multiple days. Whenever you get to this step, after you've changed it to your u's, you just integrate using your normal integration techniques. In this case, we always get power functions. And then on Wednesday of next week, we're going to have other types of functions, and you'll see how those look. Let me add it right here. And I technically missed it in yesterday's lecture. I keep forgetting this. If in the very front part, if you can do this, and it doesn't affect any of the problems that we're doing, n cannot equal -1. Because if you have -1 and you add 1, -1 plus 1 gives you 0, so it doesn't work. I forgot to add this in today's lecture, or in yesterday's lecture as well. So in yesterday's lecture, I forgot to add it, and cannot equal -1. I forgot to add that in yesterday's lecture. And it does not affect any problems that you're doing. I'm not giving you any problems where n, the power is -1. That will happen in a couple of lectures from now. I just want to make sure I add that in there. N cannot equal -1 for the power rule. I'll explain later in more detail. Sorry about that. So we're going to integrate. And it just feels like a normal problem. So this part right here should feel just like a problem from yesterday. So we have this 1/2 integral u to the 4th du. We're going to do exactly like we did yesterday. So how do I integrate this? Nothing fancy. This is just exactly what we did yesterday. It just said it's a u instead of a du. It's u's instead of x's. And I gave you problems where there was t's and v's and all kinds of stuff. That's what I do. This was your homework. You can basically ignore everything that we've done up until this point. I could have given you this part on your homework now. So 1/2, what's I got from somebody, parentheses, u to the 5th power, a 1/5 inside the parentheses, plus c. For all of you, those of you that are being quiet on this, it worries me that you don't know what you're doing. And like I said, this is literally ripped from yesterday's part of homework when we get to this type of step. If you don't know how to do this part right here of 1/2, 1/5 u to the 5th plus c, there is no success that you will get from today's homework. That's the truth. All right. So there's a lot of you know I'm getting 1 or 2 individuals that will send me a direct message and thank you and for doing that. And I need, that shows me that you know how to do it. But everybody else is just staying silent in here. When I'm deciding between grades, especially. And you're not ever speaking up ever or typing anything directly to me, I'm not going to give you that higher grade. I'm just going to let you know that. It's become way, way too much of a deterrence within this class of complete silence. There's many of you who have at times just left, and I can't even tell that. So if you're not messaging me about what you think you need to do or to speak up. Like I said, if you don't want other people to know how you're answering, send a direct message. But I do need some understanding, and I do need to know if you expect to get those higher grades or not. And maybe the grade doesn't matter to you at all, and I'll just give you the lower grade. So we do it like normal. So this becomes 1/10 u to the 5th plus c. Okay, step 6, final step. Resubstitute back the initial u for g of x. In other words, my answer was started in x, my answer needs the end in x. So my answer becomes 1/10 parentheses x squared plus 4, because that was my u, to the 5th power plus my constant of integration. And that's the process. This process will repeat over and over and over throughout your homework. The last 2 steps always become you integrate like normal, and you substitute back in your function of x. Those are the last 2 steps every time. Let's do another example. The integral of 2x plus 1 to the 5th dx. Now, this one's a weird one. That's why I'm showing you this one separately. It's not a weird one. It's actually much easier than all the other ones. When I look at this problem, I noticed I have a function. I can see I don't want to expand. Okay, expansion is out of the table. So if expansion's out of the equation, then U-substitution is going to happen. So this is an example with a linear baby. It is still U-substitution when no other x's. So in other words, because the derivative of a linear is a constant, then you don't need to go about doing like, oh, remember I said, like, is there x and is there 2 functions of x? Linear babies work a little bit different. That's why I'm trying to point that one explicitly to you. All right, so let's go through the process. So kind of step 1, I guess I could have called it step 0. We're going to use U-substitution. So what's my next step? Substitute u for the baby. Perfect. So u equals. There's a great chance for other people to step up and speak. You can't, I don't see how you can be wrong here. Somebody. Thank you for somebody else stepping up to the plate. I appreciate that. 2x plus 1. Good. Next, and the steps just flow. Next step, what do I do? Or what do I get? You can tell me what I do or what I get. I'm hoping to get like 3 more problems in. If I don't, I get as much problems as I do, and you're responsible to be able to do all the other ones. Take the derivative, all right? And so what is my derivative? So this is tricky. So what is my derivative on this problem? What do I get when I differentiate partially? You got to give me both sides. You got to give me the entire thing. How is it written? Look at the notes. It's the same thing. You got to give me both sides. It's an equals, it's an equation. There will be an equal sign in this. Everybody else just wants to be quiet. Du equals 2 dx. No, we do not have anything to do. Our whole focus is here. We're taking the derivative of what we're at here. This is our focus right now. This is our focus on the steps. So what do I do next? Well, what do I get when I do? And it's not you're solving for x, you're solving for the x terms because you're also going to have a dx on that side. So what do I get? Basically, you're just solving, in this case, for dx. And this is really just 2 times dx. This is a really simple algebra problem. 1/2 du equals dx. No replacing. I don't know what replacing means. All right. So I've done these 2 steps. I mean, I don't know if Darwin's response was in regards to what's the next step. So what am I going to do now with this problem? And more importantly, what do I get? That's what I want to know. What do I get in the next part of this problem? I usually like to put these parts on the right side of my screen just to save a little space. Yeah, I guess I can just leave it the way it was. Just to know that we're going these steps. All right, what do I get? What do I do now? Or what do I get when what do I do and what do I get? Darn, was your response in response to this step or in response to the previous step? I don't understand. So, Ariana, you're jumping way too far ahead. Way too many step jumps here. So I'm going to substitute back. Yes. And when I substitute back, you must show your new integral. You must show your new integral. You must show the substitution. So as I said, this 1/2 du means we get 1/2 the integral. It's very important to note that this 1/2 becomes 1/2 the integral in this problem. And now it becomes u to the 5th du. Like I said, every problem becomes just like that. And now what do I do? What is it that I'm doing next? Now that I'm here, I don't care about anything that's happened before. That's kind of the cool thing about this. You kind of just leave most everything behind for the most part. So what do I do now? You got to explain to me, what am I going to do now? What am I doing now? So people are trying to tell me answers, which I appreciate, but you're not telling me what I got to do. What do I have to do? What is the concept, the application, the task? Integrate. Yeah, it's just as simple. I integrate. This is where we go back to yesterday. So 1/2 parentheses u to the 6th 1/6 plus c. I integrate. And I'm not going to try. I hopefully you better know that that's how you integrate that piece right there. All right. So if you're struggling with what the next step is, that's what we're learning right now. When it comes to doing it, I'm just going to run forward because you better know how to integrate. All right. And now I'm going to actually I can clean this up. Yes, I can clean this up. But now I can just get my answer, which is 1/12 what? What am I doing next? What is this final step doing? Man, I had like 3 more examples lined up for you guys. There were some really good, trickier ones. I don't know why you guys don't want to respond. No solving. No, way off. Now we got to look back to our original. We got to open up the screen on the last one. Thank you. We just substitute the u. 2x plus 1 to the 6 plus c. Boom, and done. We resubstitute, as I was saying before. All right. I don't think I have the based on how slow the responses are into coming in. I do not have time for 3 examples. I'll limit down to the choice. I only have time for 1 more example. You're going to be forced to do it on the end. Would you rather see a substitution with a radical or a substitution with a denominator? Is that the only? I got 1 vote. Okay. All right. So the problem at hand is the integral of 3 square root 4 minus 3x dx. All right. Now this 3 in front. Whenever I see this 3 in front, what I just do is I just think of that as 3 integral. Square root of 4 minus 3x dx. That's what I do when I write it down on my paper. That's like the first thing I'll jump out and do. All right. You know what? Let me make this x squared, and let me make this x cubed right there, just to spicy it up a little bit without a constant. All right. What do I do? We know we're doing substitution, so that's step 0, step 1 / 0 is already done. So what do I do now? I'm still going to wait for responses. I have to go to the very last second. I'll do the very last second. If I just tell you what to do, it's not beneficial to you. If I just run through an example, it's not going to help you. I'm telling you, this is U-Substituion. We could make it calc friendly now. If you wish to, it doesn't hurt the problem. At some point, we do need to make this problem calc friendly. And so, yes, I agree. I like to do it. X squared parentheses 4 minus 3x squared, or x cubed, to the 1/2 power dx. I like to do that early. That's my preference. You can do it early, you can do it later. I like it now because I also see the parentheses and it helps me. Next step. So we don't do the substitution, we were defining. So you can call it U-Substitution, or you can call it define U. If you tell me substitute, that means I'm actually replacing, which is a later step, okay? So you can say U-Substitution for the next step. So U is equal to 4 minus 3x cubed. They're good. Therefore, du is equal to, this is a different problem. Can't just try to copy down the answers. You need to make sure to everybody that you're doing these problems and not just canceling. It's the same step. You need to recognize steps versus, it's not the same answer. So yes, thank you very much. -9, and uh-oh, you're missing something. -9x squared, -9x squared, I'm still missing something. -9x squared, du equals -9x squared. It's missing something. It's missing something. What is it missing? There's no plus c. We're not integrating right now. Dx, yeah, dx. You have to write that down. All right. And then I'm going to solve for x squared dx. So I get that x squared dx is equal to, oh, that's a simple algebra, -1/9 du. Now, be careful. This 3 needs to stay on. Here's my x squared dx, okay? Like I said, all these problems will always end the same. So what I do, don't forget that 3. So I get 3 times -1/9. Don't forget that 3. That was inside the problem. Integral, and we are running out of time. So now we get u to the 1/2 du. The problems always end at the exact same spot. Once I get over here, that's -1/3, parentheses, u to the 3/2, 2/3. Now I got to rush through the problem because you weren't replying. And therefore, I get -2/9, parentheses, 4 minus 3x cubed raised to the 3/2 plus the constant of integration. Farida, you forgot the 3 from in front. Don't forget that this 3 we need to bring along in the problem. And don't forget that negative as well for my x squared dx. That should fix your issue. And don't forget the x one, but I think that's just you typing. All right, your homework is a homework. These problems are the same over and over and over. All right, so what I'm gonna do on Monday is we're gonna be doing basically the same types of problems, but they're just gonna be a little bit more. And I'm just actually realizing today's problems are basically Mondays as well. Your homework tonight will mostly be problems like this with constants. All right, so your homework tonight is mostly this. So I'll have Monday's class to get questions and then be going over some problems. Tuesday's homework problems or Monday night's homework problems are basically problems. So, sorry. What I meant to say is tonight's homeworks are mostly like these 2 examples. All your problems tonight, I believe, are linear function babies. And then, what happened to my thing? Oh, I never put it. I didn't write it down in the right place. 3. Please fix this before you go. I had changed it to this, but I didn't put it in the very first problem. Your Monday night's homeworks will be more problems like this. So tonight's homework is basically a lot of problems like this. Monday night's homework is going to be a lot of problems just like that. I'm sorry for going over. That's what I said was going to end up happening as a result. I'm going to give you multiple days of practicing. So get tonight's homework done by Monday so you can ask any questions and check your homework, everybody. I'll see you then. Have a good weekend.